So let's come back to the cooperative reliable multicast. In the beginning, you have already seen that we had this example of the football stadium, right? And we said that in this case, if we have a lot of cellular links going to the stadium, there will be not enough capacity for this small area for all of the devices, right? So this was the big problem. And you remember that the solution, instead of having an individual link to all of them, we would use so-called seeding links to the station to send in content and distribute anything like a replay to the users like this. And question is now, what are the problems in such a scenario? Why should people cooperate? And what are the inefficiencies, right? We will come back to this guy who, for example, has a lot of seeding information from both sides. Is this a good thing that he has seeding from both sides or a bad thing, right? We have implemented this 2017 in a demonstrator for Nokia for the Mobile World Congress, and where we really could show what would happen if we seed in the devices like this. Here we're given displays for the users to see the quality. Also what will happen inside the stadium when we do a cooperative versus a non-cooperative event with the spectrum, the latency and the data rate per device. So very interesting demonstrator at that time. Now, the user cooperation, how could this take place, right? So in the easiest way, there will be a content on the server. This will be conveyed to the base station. The base station will now either send out all of the content individually to the users. This will take some time, or give a portion of the information to the users that they will exchange later on. So here we say we have one user getting the blue piece, one user getting the red piece, one user getting the green piece, and one user getting the yellow piece. After they are getting it, then they would just use the short range to broadcast it, and everybody will broadcast it, so that in the end you will get all of the devices, the pieces of the information, sorry. So this is what you see here in the timeline. The base station will send out the first packet, the blue one. The blue guy will receive it. It takes a while because the data rate is assumed to maybe lower than the short range. And then you shoot it out on the short range. You send it and the other have to receive it. Meanwhile, you do this exchange of the blue packet. The red guy, or in this guy, the red girl maybe, would receive the next portion and then receive it over here and do the exchange as well. And now you see that everybody will only get a quarter of the cellular content, and we will distribute it. This is not really an advantage, because you could even say, why is not everybody stay tuned to get the content directly from the base station? So there must be an advantage of getting it over the short range. And what we will show you in one of the later lectures is the energy you have to invest to get this reception of the devices in a non-cooperative versus a cooperation thing. And it has to do with the data rate. I can already tell you that, how fast you can send something on the short range rather than getting it from the cellular. Now, you can even think about a different way. You can have parallel resources. Now, the base station would send it all over at the same time. The reception takes place, and then there will be an exchange phase, right? And while this exchange phase takes place, there could be another round of content from the base station. Here we assume one thing, which is that everybody can listen to everybody. And what will happen if this is not true? So imagine something like this. Now, all of the users will get one of the pieces, but they cannot hear each other if they are across each other. So the blue cannot listen to the green and the yellow cannot listen to the red. Now the exchange looks a little bit more complicated, right? So there will be an exchange phase of the blue, red, yellow, and green, but sometimes the if you are positive the other user, you will not get the device. So there are holes in there. And because there are holes, you need a second run of exchange just to fill it, right? So the blue one will go to the green one and say, oh, you didn't get, the yellow one will help the green one because it could not get the blue one and send out the blue one. So will the green one will send out the red packet in order to help the yellow one, right? There's an exchange of these, and there are other exchanges as well. And you see already there are more packets involved now, and this will have an impact on the energy that you need for the exchange. The more you pay for the exchange, the costs go up. The benefit is clear, but the cost will go up. The question is there still an incentive? Especially if you see that there are some extra packets that you might want to receive. So if the yellow one sent out the blue packet might receive it because he said there's something from the yellow one, but it's his own packet, right? So this is a duplicate. Could be also that he receives something different, but these packets over here are extra packets which we call the duplicates. So if you listen in, sometimes you will get packets that you have already heard. And these duplicates will also have a bad impact on the cost. These duplicates are known as the coupon collector problem. If you ever have collected something like Pokemon cards, stamps, or football cards, you know if you get a certain album with a certain number of places. So I give you here a curve. If you have 125 places in your album, you know that you only have to buy 125 cards, and the rest you have to exchange with others. In order to get your album close up more quickly, what you would do is you would buy more cards to have more exchanging possibilities, right? But the most extreme is you only buy 125 for your album and try to exchange the rest with your duplicates with others to get unique cards. If you would just buy cards instead of sharing anything, then you will see in order to fill up 125 of the places in your album, you have to buy something around more than, let's say, 650 cards in order to fill up your album, right? This is really the benefit. In the beginning, you don't get so many duplicates, but in the end, you get a lot of duplicates. This is something that will destroy our benefit, and we have to come back to this problem of duplicates because this will add up for the cost, and the incentive is going away if you don't deal with the coupon collector problem. But for this, later more. So here we have seen in the cooperative reliable multicast two different scenarios. So the one is that we can use the assumption of the assumption is that the short range communication is more efficient than the cellular link that we will discuss in a later phase, and that that we can transmit less and receive less packets on the short range, that this will yield better results, right? And the first scenario will have better results due to better connectivity because everybody can hear everybody. The second scenario will be degraded a little bit because there are the so-called duplicates, right? And there is something, how can we decrease this? And no, spoiler alert, there will be one lecture on the network coding, technology that is really tailored to our corporation. But there's a whole lecture on network coding. If you would like to learn a little bit more, just go to our YouTube channel. We also have to deal with the fairness between the cooperative users, right? In the first scenario, all users have the same cost and benefit. That seems to be easy, right? But the second scenario, some users have higher costs. If you look back on this on your slides, you will see that some devices had to do more sendings than others, and some of them had more receptions, duplicates, and they might ask, why should I do it, right? Even if you gain, but your gain is lower than the others, maybe some ethical things will play a role, especially with humans. So it's not totally clear that there will be cooperation if we have the same, if we have all a gain, but the gains are different. So if you would gain €1 and the other one would gain 1,000,000, would you call this fair? Would you still undergo this kind of cooperation? Think about the examples that we had in the nature examples. There is something from the monkeys that you can learn, and it will have to do with your relationship to the players you play with, this kind of cooperation. But this we will do in our next lecture.